substitution. I'm gonna
Mhm.
switch sharing. Okay, so the U here. I cannot believe this. My
I think
pen
the issue
is.
I had was what to do with um the X on the outside. I don't know. I don't know what it was, but
All right. Okay. So the this one's an odd one where you have to actually let U equal x minus 5, and then you solve for x
yeah.
also. So x is equal to U plus 5.
Um,
And then you're still supposed to do the whole like, well, du is dx. So you have the integral. X is really U plus 5. X minus 5 is U to the 1/3 power, and then du is dx, or dx is du. So
I don't
now
know if I've ever like. Why did you have to do U+5?
you're solving this for x. It's a technique that I know about, that I'm telling you now, that so that you know about, but it occurs in this style of problem.
Okay.
So it's there's all these different techniques of integration, and this is just one of them, because you can't do it directly. So I don't have a I don't really have a good reason for like why. It's just this is what you do in this type of problem. Um, because if you don't solve for x, you end up getting over here. You get the integral of x,
Yeah.
U to the 1/3 du, and you're
Yeah.
like, what do I do with the x? Well, yeah, that's why you
Right.
have to solve
Because
for it.
like the way that I've done these problems, like how I was taught was like probably how we're gonna do it. Like, um, you do I'm trying to think. So like x-5 equals u, and then um du equals 1. Is that y? You know what I mean? Like it's like du equals 1 dx, and normally like you'd be able to do like, I don't know, I can't explain it. Or like the way that I've done a different problem is like the like you do like you solve for you. I can't explain it. Like
Yeah, I mean, normally that is the case. Like normally, when you take the derivative is the
yeah,
derivative cancels out. But this is this other case. They
okay,
give this one in regular calc classes, and yours just it's an exception to the rule.
okay,
Okay, so um, you've got u. So I just multiply in, and then you're integrating this. So it becomes u to the 7/3, 3/7 plus u to the 4/3, 3/4 plus c, and then u is really x minus 5. So you
hmm,
have x minus 5 to the 7/3 plus 15 over 4 x minus 5 to the 4/3 plus c.
okay.
The next one is actually 74, is actually very similar. Do you want me to enter the answers in to WebAssign?
Um, if it's gonna take up
It,
time, then no.
I wouldn't recommend doing that. Um, okay, so 74, it's the same thing here. U has to equal x plus 4,
Right.
because that gets, but the problem is du is dx. So if you just substitute this in, x over the square root of u du, you're like, wait, I have an x. So that tells you to solve for
Oh,
x up here. So
okay.
x equals u minus 4. The
Oh,
integral of u minus 4 over square root of u du. This still doesn't look great,
mhm.
but if you divide these both by u to the 1/2 minus 4 over u to the 1/2, you get u to the 1/2 minus 4u to the minus 1/2. And that's what you're integrating. So you have to like do a little bit of manipulation to get it to where you can actually use the power rule. So the power rule is u to the 3/2, 2/3, and then here it's u to the 1/2 because you add 1 to the exponent. So this becomes -8 because 8 times 1/2 gets you back to 4 plus c, and then you solve for.
Put u in. Well, the only thing I'm confused is, oh, okay. Could you not have done it like u minus 4? You can't do time.
No, you have to break these up into two.
Okay.
The two pieces. And it's not an obvious thing until you've seen it and done it a few times.
Right. And then
so then the x plus 4 comes back in, so it's 2/3 x plus 4 3/2 minus 8 x plus 4 to the 1/2 plus c. So I'm going to post 75 in. You can tell me whether you want us to work through it or not. And then we can, where I can go back.
Oh, yeah. This one, like, normally I know how to do them, but I was getting like a really weird number because you're putting it to the negative x squared.
It's going to be a pretty small number,
Okay.
but yeah, so like I don't like this window. Like normally it would be something that goes into 4.
Yeah.
So, but the way this works is 10 minus 0 over 4 equals 2.5. So you start with 0, and then you add this is delta x over here. You add that, so you get 2.5, 5, 7.5, and 10. And because it's a left sum, you're going to do 1, 2, 3, 4 of those. So your sum, your left Riemann sum is delta x times f of 0 plus f of 2.5 plus f of 5 plus f of 7.5. And you're right, you will get some things that aren't great. So this is 2.5 over here. F of 0 is 3e to the minus 0 squared plus 3e to the minus 2.5 squared plus 3e to the minus 5 squared plus I don't know why I put that in parentheses. It doesn't need to be in parentheses. Plus a 3e to the minus 7.5 squared. And you get whatever you get when you do all that.
Right. I think I was having, like, I did that, but I don't know.
Yeah, I mean, this is pretty calculator intense for that. Let me go back and share the screen so that you can tell me if you want us to do this next problem. I mentioned last night that it was 76, like we didn't see one like this. We can certainly do it if you would like.
This one, like, just I don't think it would be on the test because it's so hard to like know what the values are.
It sure is.
So that's why like we don't have to do it. But I want to see if I calculated the other one right.
The 175.
Yeah, I'm still plugging it. Oh, I got 7.51.
3 decimal places.
7.4,
I guess, actually.
It's 7.5144.
Okay, I'll try it. The one that we had on your exam or homework was much simpler. It was like an x squared or something. It wasn't anything like this. Didn't like that.
I mean, it's fine.
Did you multiply by the 2.5?
Yeah.
That's another thing. Okay.
I know how to calculate it, so I don't think it's. Well, I don't know. It's weird that it didn't. work. I didn't do any parentheses. Um, I don't know. That's weird. It's fine. Okay.
Okay. So you got these right. That's good. This one,
This one I like was so confused because I looked up the integral calculator and it just took a I don't even know like the last step was so confused about like
okay. I will, first of all, it can't be negative because it's an area under the curve.
can you just plug this into the calculator?
No, because it's a fifth degree, it might work, but the, what your calculator uses is what's called Simpson's method, and it's good up to a third degree usually.
Okay.
Second degree for sure, third degree sometimes. I know that's more information than you wanted, but the correct way to do this is to u equals 3x plus 1,
Yeah.
du equals 3dx. You're integrating from 18 times u to the fifth. Dx is du over 3, so that makes this the integral of 6u to the fifth. This is a good one to actually use the integration change, like u of 0 equals 3 times 0 plus 1, which equals 1. U of 2 equals 3 times 2 plus 1, which is, 7. So you're integrating from 1 to 7. And the antiderivative of this is just u to the sixth.
Wait, then why did they give you 2 and 0?
Because the 2 and 0 work with x, but when you do the change of variable, you're supposed to change the integration. You don't have to. You can leave these as is. You just, when you find the antiderivative, you have to then go back to the original ones. But this is a shortcut. If you've never seen this before, I probably shouldn't have shown it to you.
I know maybe we learned about a shortcut, but I don't remember it.
Okay, so forget about that for a moment. It's the integral of 6u to the fifth du.
Yeah.
So the antiderivative is u to the sixth, and u is really 3x plus 1 to the sixth. And then you're evaluating it from 0 to 2. So it's 3 times 2 plus 1 to the sixth minus 3 times 0 plus 1 to the sixth.
And how do you know you always do the top one first?
Yeah, it's always the top minus bottom. So this is 7 to the sixth, which I have no idea what that is, minus 1 to the sixth, which is 1. So it's whatever that is.
117648. Okay.
Okay, minus 1, maybe. I don't know. No, I guess that is it. Can I go on to 80? The next one? Okay, so 80 is an integration by parts question. I'll snip it in. So the integration by parts, it tells you to use that. That's uv minus the integral of v du. So in this scenario, you want to set u to be the thing in front of the e, so the 9x, and the dv equal to e to the minus x dx. And this is the only way it works. Like if you swatch, if you do these, if you flip them here, like where dv is 9x and u is e to the minus x, well, then it doesn't work. So du here is 9 dx. And when you integrate over here, you get minus e to the minus x. Okay. And if that's not clear, we can go through that, but hopefully that's clear.
Yeah.
Okay, so now you're just applying this formula, u times v. So it's minus 9x e to the minus x. You got that part. Minus the integral of v du. So this is plus 9e to the minus x dx. And this is the part that was lacking. So you have to find the antiderivative of this. We already did e to the minus x. And keep in mind that this 9 could be out here. So it's like taking the integral of e to the minus x, which you already have, becomes minus e to the minus x, and that 9 just stays in front. So you're just missing that extra little piece. '81 is also an integration by parts, so we can do that next if you'd like.
Okay.
So I used to actually meet some people at Pima and help them with exams back, it was many years ago, but they're the proctored ones are tough. You just don't have a lot of options to get help. So here again, u is going to be 1 minus x, and dv is e to the x dx. So on the left here, du is minus dx, or minus 1 dx. On the right, v equals e to the x. When you integrate e to the x, you get itself. You take the derivative of e to the x, you get itself.
Why does dv go to v? Like, what does that mean?
Oh, you're integrating. Okay, so it's like this. The integral of 1 dx equals x, and that 1 isn't needed. Okay, but this dx is always here.
Right.
What is the derivative of x?
1.
Y prime equals 1. Really, it's dx. So when you're going backwards, that's what we're doing in this step.
Oh, so it's like the opposite of the u
Yes.
and du.
Yeah, it's the derivative is up, the integral is down.
Okay.
So we'll do this uv minus the integral of v du. U times v is 1 minus x e to the x minus the integral of v du. So this negative goes with this one, it makes that a plus, e to the x dx. And the integral of e to the x dx is e to the x.
Negative 1 dx. So
sorry, I guess I got sidetracked here. So it's just like that.
Okay, got it.
Okay, so the next one is not. I guess it is integration by parts, but it's a more detailed one. I wouldn't recommend doing 82. I wouldn't recommend us doing it. It's a more advanced one. I would recommend us doing 83 though, because it's a slightly different variation on integration by parts. So what MR is saying is that this is like an advanced, like level 2. Like you wouldn't see that on a test.
Oh.
But I can certainly do it if you'd like.
No, I don't want to do that.
Okay, 83 we will do. 83 is it's kind of like that question we first started out with, where you have to know that it's an exception to know what to do different. So normally you set u equal to x to the 5th, but whenever there's an ln, that's what u becomes, and dv is x to the 5th dx. So du over here is 1 over x, and here v equals 1/6 x to the 6th.
Okay. And it's uv minus v du?
It's still uv minus the integral of v du, yes. So this time u is natural log of x, and then v is the 1/6 x to the 6th minus the integral 1 over x times 1 over 6 x to the 6th. 1 over 6 natural log of x to the 6th minus the integral. So I'm going to bring that 1/6 out. The 1 over x cancels with x to the 6th to make it x to the 5th.
Okay.
And then you integrate this, you end up getting x to the 6th over 6, but you've got this 1/6 out in front. So it ends up being that you multiply the 1/6 then, so you get 1/6 natural log of x to the 6th minus x to the 6th over 36 plus c.
Why did you have to do it again?
Do what again? The integration or
Yeah.
the you always have to do the integration again. Like you're always integrating the VDU. The VDU always gets integrated up here. Is that what you were asking? I'm sorry. Maybe.
Yeah.
Okay. Yeah. Like we've always done that, or you always do that. Okay. 84 is a more sophisticated integration by parts, so I wouldn't recommend that we do that. I'm going to snip in 85 because this is one that you'll definitely see on the exam. This one can be done in your calculator. Let me get to where I can snip it in. So if you recall, I said, okay, it's from A to B, so -3 to 1. And whenever it's between, if you use the absolute value function, you can put them in any order and just throw this in your calculator. So I think since I reminded you of this now, I want you to try it again and see if we can get the right answer, not worrying about the work.
It's negative 13.3.
It has to be positive because it's absolute value.
Oh.
That's critical. That's super critical.
Where's the absolute value button on it? You know?
I want to say it's under math. You were able to find it the other day, so I can also look.
Oh, yeah. $13.67.
Okay, do a math enter on that and give me the fraction, because that's what it'll want here.
41/3.
That sounds pretty correct. So let me just enter that in here into the WebAssign.
So when I was like looking at the videos for this, it said you had to do like the one that's intersects, like
That's
all
right.
the work is like
Yes.
like the one that intersects like on the top.
Yeah.
Like, did you know that, or did you just do x minus x squared because that was the order?
When you do the absolute value, the order doesn't matter. What I'm showing you is a shortcut that they would never teach you, but it does work. It works every time.
Oh, okay.
Every time. There's no exceptions. This one's e to the x minus x from 0 to 1. But it's equivalent to the integral from 0 to 1 x minus e to the x. So what you're supposed to do is figure out which one's on top, which one's on the bottom, and do that. And if they happen to like intersect, like let's say one's on top part of it and one's on top of the other part of it, you're supposed to break them up into two integrals. We're just shortcutting all that.
Oh, I did the wrong one. 1.22.
So this one wants you to go to 3 decimal places. So you said 1.22 and then
1.218.
Yeah, that looks good. Let me snip the next one in before I submit that. Oh. All right, so this one, again, it's kind of the same thing. You just, you find the absolute value.
They give you a range. But that's just when you set them equal to each other, right?
Yeah, oh, this one, okay, I'm sorry, this one is slightly different. You don't know what these graphs look like. So you don't know what I'm sorry, you don't know the A to B. Like you don't know what window it is. So these ones you do have to graph. So x squared looks like that. and then x to the fourth, I want to say is a little thinner and looks like that.
Mhm.
So the and then it's the same thing on this side. So I guess it's the integral from these intersected from -1 to 1. So you would have to graph these to figure out where they intersect, or you set them equal to each other.
Yeah.
It's like, where does x squared equals x to the fourth? And then you can write x to the fourth minus x squared equals 0. And then you can factor out an x squared, so you get x squared minus 1 equals 0. And then you can get x minus 1, x plus 1.
But then what about x squared equals 0? Isn't that 0?
That's at 0. That's where they intersect. And then they intersect at 1 and -1.
So how do you know which one to use?
Well, you're supposed to do one integral from to get this region. You're supposed to go from -1 to 0 plus an integral from 0 to 1. But you can actually just overlap them.
Oh,
Like, you can do them all together. So it's the integral from -1 to 1, x squared minus x to the fourth dx. This one might not work because of the x to the fifth power, but we can.
I got 0.26.
Can you can you turn that into a fraction?
Yeah.
Because it should be 1/3 x cubed minus 1/5 x to the fifth, evaluated from -1 to 1. So it ends up being 1/3 minus
Oh,
1/5
yeah. I got
minus.
4/15.
Yeah, that sounds right. So you said that's 4/15. So this is plus 1/5. So you end up getting, anyway. You get. I think that's right.
Yeah.
Okay. So 88 is the last one of these that we'll do in this section, and it's they give you the numbers. And then the other thing you're looking for, it doesn't say here, but it says round. Whenever you see the rounding, that means you can do it in your calculator, because it's going to do the rounding for you.
Okay.
So again, it's integral from -4 to 1, absolute value e to the x minus. Now you're minusing this whole thing, so it's 2x plus 1 in parentheses like that.
And then how did you know to put one, where to put 1 and where to put -4?
It's always smallest, smaller to larger, I guess.
Okay.
If you do it the other way, you'll get a negative number doing this.
Oh, right.
Which should really cause you to pause, like, and say, "Huh, why is it negative?"
I got 13.263.
Okay. All right. So the next question here, 89, is the average value ones. There's the first part, which is to actually find the average value, and then there's the next part of the graph. So we'll deal with the first, finding the average value. So the average value, it's the same thing we've been doing, with one little extra step that's down here in the front. It's always 1 over b minus a. So it's 1 over 1 minus a minus 1 out in front. So you do the same thing you've been doing, and then in this case, you're gonna multiply by 1/2.
Okay.
So do you want to give that a give that a try in the calculator?
0.25.
So like a fourth.
Yeah, 1/4.
Yeah. So then let me share my screen here because I want you to see the importance part of of the of this. It should be 0.
What should be 0?
The average value.
Oh.
Yeah.
Um, do you think it's because I multiplied it by 1/2 at the end?
No, because this inner part is 0.
Um, okay, yeah, I got 0 when I plugged in one. I like plugged in 1/2 and then
Okay.
integral, so then I got 0.
So the reason I'm bringing that up is the red line here is the average value. So the red line represents whatever number you get here. So if you get 0 in the box, which is what we just said, the line is y equals 0.
So it's that first one.
Yes. Yeah. So let's go to the next one here. So this one, see how it's just to round your answer to decimal places. That's a given that you're going to do it in your calculator.
Yeah.
So you're going to integrate e to the x from -1 to 2 on your calculator. And then you're going to divide it by 1 over b minus a, which ends up being 3.
Oh, so, okay. So 3, and then you
Yeah.
go. $21.063.
So that's way too big because if you look at the graphs here, the one that has the same, it's going to be around 2 here. So make sure you're integrating e to the x -1 to 2, and then you're just dividing the answer by 3.
Oh, so it's 1/3.
Yeah.
I put 3 in front. That's why.
Okay. It's 1 over b minus a, and a is -1, b is 2. It's right minus left kind of thing.
Do I still need to be doing absolute value?
Not for these. The absolute value really only applies to the ones that are area between.
Mm-hmm.
Between ones are absolute values.
I got 2.34.
2.34. Yeah, that looks right. So yeah. So see how this graph is at y equals 2.34, like you just said?
Yeah. That's just what we're looking for. Okay.
Okay. I've suggested we not do 91.
Okay.
I probably need to look back in our notes with how to do 92.
I remember it was like n minus 5.
Yes. I'm just scrolling back through our old notes to find it. Okay, so I did find it. I need to copy this in. Okay, so I found it. I'm going to share my screen. Share. So your problem is you're integrating f of x equals x third with a 5-unit average, so n equals 5. So since n is 5, it's 1 over 5 integral x minus 5 to x of x third dx.
And can you
So
just plug that in?
you find the antiderivative of this, which is 1/4 x to the fourth, and then you evaluate it from x minus 5 to x, and you always put the top in first. So that's going to be 1 over 20. That's this part. And then it's x to the fourth. You're putting this x in for x, so it just becomes itself, minus x minus 5 to the fourth, like this.
And you put that in?
Yeah, that's the answer.
Oh, that's the answer. Okay.
And then you graph it to get the red, figure out the red line. And it looked like you had to look for like where it crosses the x-axis to. Let me share the other one. If you see the graph here, this one crosses the x-axis around 2.5. This one's like 1.8. This one's at 1.2. This one's at 3.2. So what you're looking for is wherever that new function that we just came up with crosses the x-axis.
Okay.
Okay, so you got some of these right. That's good. Can I go through 94?
Yes.
Okay. Oh, 94 is the one where it. Let me actually.
Oh, they give you that's why.
Yeah, it. If you're not paying attention, which when you're in a test, it's very stressful. You need to do that. So you have to solve. You have to solve this for p. Solve for p, because see how this one is solved for p in the previous one.
Yeah.
So in this case, p equals 150 minus q over 2. Okay. And
oh wait, are you on your other screen?
I'm sorry. Yes. Let me. I thought I could get through an entire lesson without screwing that up, and I didn't. Yeah. So you solve for p, just like this one solved for p already. And the formula we had to write this down, but it's you're integrating from, we'll get those bounds shortly. It's 150 minus q over 2 minus p in this case for consumer surplus. Okay, and then I'm sorry. Yeah, and then we need to figure out where these intersect. So you substitute that in. You get 15 equals 150 minus q over 2. And you end up finding that a q is about 120. Or it's exactly 120. So that's how you get the upper bound. And once you have all this, if you can enter it into your calculator correctly, you can get the answer this way. It says to the nearest cent, so that's another indicator that it's a calculator problem.
I don't know if that's right. I got, might have been a parenthesis issue, but I got 3,600.
Sounds reasonable.
Okay. Just because there's no sense. I don't know if that.
Okay. Given the amount of time we have left, I would suggest skipping 95. It's another surplus question, and moving to 96, which is there's converging ones.
Okay.
So let me new share. Might have to talk through some of these verbally.
Yeah.
So e to the minus x converges from 0 to infinity, but it does not converge with the other ones. Like I think you might have that one down here. Nope, you don't. So this one converges and it goes to 1. Okay.
Why?
You end up evaluating e to the minus infinity, which is 0. should probably give more explanation on that. What is the antiderivative of e to the minus x is minus e to the minus x. So when you evaluate e to the minus infinity, that is 0. Okay, but when you, I'm not. Let me. I guess I gotta explain that. I'm not doing a good job. Get that over here. So if you have the integral from 0 to infinity, e to the minus x dx, the antiderivative is minus e to the minus x. So it's minus e to the minus infinity minus e to the minus 0.
Mm-hmm.
So this right here is 0 because negative infinity, it becomes really 1 over e to the infinity. And even though it's negative, that doesn't matter. E to the infinity is a huge number. 1 over a huge number is 0. The fact that it's negative just means it's still really close to 0. These two negatives make a positive. E to the 0 is 1.
Okay.
That's why it's just 1. Okay, let me snip in 97 because it's kind of the same type of problem that we have to be able to do. I was trying to shortcut these, but it didn't help much. So I'll do it the right way, the traditional way here. Okay, so this is really x to the minus 1/3. So the antiderivative of that is x to the 2/3, 3/2 out in front, and we're evaluating that from minus infinity to minus 7.
Mm-hmm.
Is that okay?
Mm-hmm.
So we're taking 3/2 of minus 7, 2/3 power, whatever that is, minus 3/2 to minus infinity to the 2/3 power. So this is a number. That's nice. Well, we can figure it out if we need to. But the problem is over here. You may not remember exactly what this means, but it means the cube root after you square it. Mm-hmm. So the cube root of infinity is infinity. And when you square infinity, it's infinity. So this is effectively some sort of infinity. Could be plus or minus. We don't really know. Don't care. So no matter what this is, when you add it to plus or minus infinity, it diverges. $98 is pretty complicated. Don't recommend doing that. 99, same thing. 100 is kind of the same thing. So is there another question on here? Let me reshare it that we can go through. We got maybe time for one more. Possibly this one if you wanted. It's a producer surplus, which is different than the consumer surplus.
I'm trying to look and see if there's really quick. I had a question on 62. I don't know. I didn't know what to put for that last part because I knew that I thought just the maximum revenue was setting it equal to 1. But so I put it in for the maximum revenue, but I guess that's weekly.
Yeah, the maximum revenue comes from it comes from that price, but you have to put that price into the revenue function, which you don't have. The revenue function though is 912 minus 19p times p. If that didn't make any sense, let me.
I did it like the way I did it was like you do like the negative derivative times p over q, and then set that equal to 1.
That gets you the price though. It doesn't get you the revenue, and there's a difference that I guess isn't clear. So let me explain that. This is the price that gives the maximum revenue. Revenue is price times quantity. So it's price times 912 minus 19p. So when you take this price and plug it in here and here, that's where you get your maximum revenue. So what you found is the place on this curve where the minus p over q, dq, dp, where that equals 1. That's right there, and that's you found that price, but you
Mhm.
need the revenue.
So, is it, so would that be like a bigger number? Because I
Yeah,
got
it's pretty big.
10,944.
Yeah, yeah. Okay, stop here. We'll have to stop here. Think about what I said and let me know if I can be of assistance, and I'll send out these notes shortly.
Okay. Yeah, I'll probably text you tomorrow.
Okay, sounds good. Thanks, Emma.
Okay, thank you.
Bye.